Welcome to the session 4 on product design of Mobile Lab. In this session, we will be discussing about the other interfaces to the baseboard like power supply, piggyback board, and the complete cabinet part of it as a whole product. Since the board, we have decided to use the linear power supply, we will be using a step-down transformer, two step-down transformers. Right, the input is coming from the AC mains, 230 volts AC mains, and the output of the step-down transformer is 18018 3-pin and 018 2-pin. So on our baseboard, as you can see, 18018 3-pin is connected here and 018 is connected here. Right, so these are the two things which are giving the power to the board. Okay, so let me show you physically. This is the board which I was talking. Now you have one 3-pin connector, one 2-pin connector, where you can plug in these 3 pins to 3-pin connector and 2-pin to the 2-pin connector. Okay, so after connection is what you are exactly supposed to do this. Okay, so then if you connect your power supply AC mains, then the board is powered up. The first indication is on your board, there is a microcontroller. There is a LED is there which will indicate the power. Or through multimeter also you can measure it. Okay, let me show you through my presentation. So this is what your adapter 18018 and 018, which is the step down AC. Otherwise the board is connected to this power adapter where the input is 230 volts AC. So finally the cabinet, right, I mean once it is fabricated all the components, so the system looks like this, right? There are two types of products as on today. One is meant for embedded workbench like IoT applications and embedded systems. Second product is, that's what so far we have discussed, analog and digital electronics workbench. There are some few connectors, male to male, male to female, or female to male. These connectors will be there. USB connector for programming purpose of the CPU, and this is AC adapter. Also some electronic components will be provided to you for experimenting by using these sockets. As far as a digital electronics practical is concerned, so far I have explained is good enough. These resources are good enough to perform digital electronics practicals. However, if you want to perform the practicals of LIC, BW, analog and all, we have separately designed the piggyback boards. Right now I am talking about one piggyback board, that is other than the base board, called linear integrated circuit. So this board is exclusively designed to implement linear integrated circuit experiments, at least 14-15 minimum you can implement. So the heart of any linear integrated circuits is, as you can see, ICs like 741 or 111, LM111 or 555, or regulator called IC 723. These are the mostly used integrated circuits for performing these linear integrated circuits or analog electronics practicals. What you can say is there are sockets for every pin. It is brought it out on a 4-pin connector. So any of these 4 pins you can use it for connecting to either VCC, ground, input signals or output signals. So one pin is connected to 4 pins of the Burge strip, which is a male one. Similarly, you can see 741 is a 8-pin connector and a 555 is once again a 8-pin connector. Uh, at least as you can see, looking at the 741, the positive supply and negative supply, wherever it is there, right? We have already connected a decoupling capacitor so that the power is already there. Only you need to take care of the rest of the inverting, non-inverting inputs. But otherwise, whatever is the positive supply, negative supply required, it is already provided. Similarly, you can see IC 555. In the same fashion, the ground and VCC is already provided with a coupling capacitor. Rest of the components is your choice. So like any integrated circuit, what you require is resistors, capacitors, diodes, or maybe in some cases transistors, some switches. So we have provided a standard resistors, few ohms to a few kilo ohms. Similarly, capacitors like nanofarad, picofarad, microfarad capacitors are there. So looking at these standard experiments, what generally done in the laboratories, those components are already there. So two ends of the components is soldered to these 4-pin connectors, Burge connectors, male connectors. So you can join wherever you want to this operational amplifier. Say for example, pin number 1, you want to connect it, take a female connector of the jumper wire. One side you connect it here, other side you connect it here. As good as this resistor one end is connected to the other end of the integrated circuit. Similarly, the power supply. You can see plus 15 is available here, and the other supplies like minus 15 is available here, 3.3 is available here, plus 5 is available here, ground is available here. So you can whichever is the operating voltage, you can choose that and you can connect it to these integrated circuits. Similarly, like resistor bank, we have a capacitor bank. You can choose whichever is the capacitors you want, wherever you want to connect, and diodes are also available like power diode and switching diode. Okay, and 2N 2222 high frequency transistors, 2 transistors are provided. If you require any transistor as a part of the driving circuit, you can make use of it. And as a jumpers, right, these 3 are already short circuited. So if you require extending the wire, maybe you can make use of it, right? But most important part, that is the signal conditioning. As you know, the signal conditioning is there on the baseboard, right? That is irrespective of your operational amplifier working. It could be on plus 15, minus 15, whatever. But the signal conditioning takes care of bringing the signal to 0 to 3.3 volts. So that is there on the baseboard. Your job is whenever you want to display the waveform, right, which is a excursion of plus 15 or minus 15 or plus 5 volts or whatever, you make use of this baseboard interface pins. They are provided here. Similarly, on the baseboard interface 1, baseboard interface 2. So on these pins, those signal conditioning inputs are there. So whenever you want to measure those signals, you give it here. Also the outputs. Outputs means like function generator or arbitrary function generator. Those signals are after amplification, they are available here. On the PCB, you have the potentiometer, adjust their amplitude, adjust their offset value, and after that the signals are available on the piggyback board, these IO slots. So you can make use of those signals as a part of your circuit. So outputs you can connect it to the signal conditioning circuit. Inputs you can use as a part of your circuit, and at least 8 analog signals you can at a time give it to the microcontroller's ports, which is scaled down to 0 to 3.3 volts. Similarly, you can also make use of GPIO lines. There we expect the GPIO lines are operating from 0 to 3.3 volts. So we wish that all GPIOs at any point of time do not exceed more than 3.3 volts. That is the assumption we have made. So whenever you use any components, the input lines should be 0 to 3.3 volts. That is a tolerance or operating voltages of the microcontroller. That is the only precaution you have to take it. Otherwise, now this is a, as you can see, a board which will take care of all the experiments of analog circuits. So most of the time you are playing with this design. I mean, in fact, you are designing your own circuit, because this is not a pre-fabricated circuit, right? All the pins are available to the user. Now it is your choice what you want to build, and reconfigurable in the sense you are free to once again remove all the wires and redesign it. So absolutely no need of soldering or those zero PCBs, no loose wiring, right? It's because these are all professional male to male, male to female, or female to female connectors. So there are no issues, or if you find any wire there is a fault, just throw it. You don't need to use that wire again. So with that respect, I will say, whatever we thought of addressing the issues of remote lab, how to provide a lab, right? As you can see, all these components we have provided. Generally, we are supposed to keep them in the racks during the practicals and we issue it. But now these are the things already mounted. So no loose connections or no misplacement and all that stuff, because they are there on your board and each one of your board, and they are available at your doorstep. So what your focus is all about the design part, not the typical soldering or or maybe understanding the components part. They are there already. It's available to you. Just you have to listen to the video of how to perform a practical that we will be doing very soon for every practical. But otherwise, in short, I hope you understood what is the concept of baseboard and what is the concept of the piggyback board. Let me show you how the piggyback board looks like, right? So your piggyback board is this. Okay. So whatever so far I have explained you, on the back side there will be, you can see those male budge strips. Okay, where on your baseboard, okay, you have the provision for inserting the piggyback board here. You can see one here, second on top, and left and right. So exactly you are supposed to insert into. This is how it goes, right? You have to carefully make sure this will match. Okay. Okay. So once you mount it, okay, whatever you see is a two-layer thing. Okay, on top what you see is a piggyback board, and the bottom portion which is having a signal conditioning, you need not worry, because they are anyhow brought it on the pins of the piggyback board. But only thing is the right side portion, that is your 7-segment displays, right, or your LED display, switches, LCD display, they're as it is available. Okay, you can still use it for your piggyback circuit, You can connect these things, outputs, you can connect it from here, or switches as inputs, you can connect it here. While programming, whenever you want to program it, just make sure there is a USB connector here, right? This is the USB. That is the one you connect it to your computer's USB for programming purpose. While after compiling, I will show you experimentally also, after compiling, when you transfer the program, even if this power supply is not there, right? Your transformers, two transformers, 018 and 18018. Actually, 018 is not generally used. You use this 2-pin 018 only when you require a variable power supply. Otherwise, if you want a regulated constant DC volts power supply, this need not be used. Only this 3-pin connector using. But to program this microcontroller, you don't need this power, because the power required for this microcontroller is coming from the computer's USB. So computer's USB power we have not used for any of your experimental purpose. The 5 volts which you are using for digital electronics or maybe analog electronics is derived from this transformer, not from this USB, because we do not want to load the USB of the computer. USB of the computer, though it gives a regulated DC of 5 volts, but the power rating is half ampere. So by any mistake, if you short circuit, then it may load or damage your computer's USB. So the USB of this microcontroller is only meant for programming this, not to power this entire board. Okay, so power this entire board happens through this one. So whenever you want to program it, only this your microcontroller, or at the most the function generator or LCD, these are all connected to the USB power. That means this only CPU part is taken care by the computer's USB, but rest of the power is derived from these regulators as well as these transformers. Okay, so that's about the what do you mean by the, in computer we say daughter board and motherboard, but in our case we are saying base board and the piggyback board. Piggyback board we use it only when you want to perform those LIC, BW, EDC practicals. For performing digital electronics practical, you don't need a piggyback board because all the sockets are there and the resources are there on the base board itself. So now the further videos all about the more technical details about how this board is designed, right? Most importantly, I will be using the circuit diagrams and will be explaining each and every section, that how this signal, most importantly, the signal conditioning is designed on this board so that it is converting the high voltages into the acceptable voltages of the microcontroller. Of course, similarly, the your function generator itself, how the level shifting and amplification factor is done in your function generator as well as the arbitrary function generator. Rest is traditional things like power supply is a conventional regulated power supply, but still I will brief you about which components are placed where and for what purpose. Alright, so that's about the concept of analog and digital electronics mobile lab and how we have realized by using this what we called as a base board and the piggyback boards. Thank you.